Hello, everyone. So I'm coming back today just to show you, in a simple example, how to prove a given set is a vector subspace, right, of a given vector space. So this topic does not yield to big calculations, but what I noticed from past semesters is pretty much many students, don't do it properly, pretty much, right? So that's why I felt important to record this video, right? Short video to show you how you approach this kind of questions. Okay, so for the vector subspace, we're going to verify three axioms, right? We have it's not empty, right? So it's not empty. W is not empty, and W is closed under addition, and W is closed under multiplication by scalar. So we're going to verify here the three axioms. W is not empty. So, and the best way to prove a vector, a vector subspace is not empty is to prove that actually the null vector is in W. Okay, so because you cannot be a vector space or vector subspace if you don't contain the null vector. The null vector has to be in there. So here, pretty much, uh, this case is kind of obvious because the null vector, which is the triplet 0, 0, 0, of course, is in W because 0, 0, 0 is of the form because it is also, I mean, it is obvious, but let me just write it down, because it is of the form 3, 0 plus 2 times 0 minus 0, right? X and Y and Z, they're all zeros. 0 plus 5, 0, right? And then negative 3, 0. So, you see? And that is of the form of any given element of W. Okay, so that means W isn't empty. So now let's choose closure under addition. Closure, closure under addition. So here we have to give ourselves like two general elements. And here from my past classes, I see students giving examples. You cannot prove a generality with examples. A generality must be proven in general. So let me give myself two vectors in W. So U1 equal to 3x1, right, plus 2y1 minus z1, comma, x1 plus 5y1, comma, and then negative 3z1. That's an element of W. And U2, right, equal to 3x2 plus 2y2 minus z2, right, comma, x2 plus 5y2, comma, and then negative 3z2. That's also another element of W. Every element of W must be in that form. So x1, y1, z1, x2, y2, z2, they all real numbers. Okay, they are element of R. So now the question is, what about the addition? What about U plus U1 plus U2? You see, U1 plus U2, and here by definition, by definition of the addition of uh, two triplets, we add the first coordinate. I mean, the first component, the second component, the third components together. So if I kind of skip steps right here, it's going to be 3 times x1 plus x2 plus 2 times y1 plus y2 and plus 3 times, no, minus, I'm sorry, is minus 3 times z1 plus z2. That's the first component, comma. The second component will be x1 plus x2 plus 5 times y1 plus y2, right? And the third one, comma, would be negative 3 times z1 plus z2. You see? Now, why this one is an element of W? Why? Because if I call this is capital X, that's capital Y, and capital Z, then it's going to be what? Of the form 3 capital X plus 2 capital Y minus 3 capital Z. That's the first component. And then capital X plus 5 capital Y is the second component, and negative 3 capital Z, you see? And this is exactly an element of W, okay? And that proves that W is closed under addition, okay? So, and as you can see, this is almost calculation free. So for many, many problems of this type, we don't expect like massive calculations. Is rather how to present your argument. That is rather than a big calculations. All right. So right here, the last one is closure under multiplication by scalar. Right, under multiplication by a scalar. See, so we multiply a vector by a scalar. The multiplication of vectors themselves, is kind of, we don't multiply two vectors. You have another type of multiplication which is not your regular multiplication, right? It's a cross product. Okay. So right here, I give myself again u equal to 3x. Here I don't need to call them x1, x2 because I have just one. I just need one vector. 3x plus 2y minus 3z, right? And comma x plus 5y, comma negative 3z is an element of W. And then I give myself a scalar C, which is a scalar, which is a real number. So I'm wondering when I multiply U by C if I get an element of W, basically. So is CU element of W, right? So this is just we asking. Okay, let's do the math. Again, here, this is not heavy math, by the way. CU is what? Is you multiply the first component by C is 3CX plus 2CY minus 3CZ, right? Comma, CX plus 5CY, comma, and negative 3CZ. Same thing now. If I call CX, if I call CX capital X, CY capital Y, CZ capital Z, right? Then it's going to be 3 capital X plus 2 capital Y minus 3 capital Z, comma, capital X plus 5 capital Y, comma, negative 3 capital Z. You see, again, this is exactly the form of an element of W, right? So I verify the three axioms for something to be a vector subspace. As you can see here, it's not calculation heavy, so do not expect it to be calculation heavy, right? So, but it's very, very important to lay down your argument, right? It's very important for the reader, for the grader, to lay down, to write it properly. All right. Thank you very much.